Problem 2 from our textbook is actually probably, I'd say, one of the most difficult problems in the section that our author presents to us. Not so much because the situation is difficult or that we can't understand what's going on, but really just there's a lot going on for sure. We have a bunch of different units in addition to some relationships that we want to be aware of. So let's start looking at this one and solving it together. It says the standard football field is 120 yards long and 160 feet wide. How long would it take Forrest Gump to mow a football field if his mower cuts a 30-inch wide path and travels 4 miles per hour? So again, the first time I read through a problem, I'm just trying to get a sense of what information is being given, what sort of situation do we have happening. So I can start understanding the problem and diagramming out what's going on. So I drew a rectangle to represent our field, and we can go ahead and start labeling some of the measurements that they told us. So they said that one side of this is 120 yards, and the other side is 160 feet. So we can already start kind of telling, just by looking at our units, that there's going to be some unit conversions happening. Because if we're going to do math on these, we need the same unit for them to be like terms to do any math on it. But we'll worry about that when we get to it. So the next bit is to go ahead and pull out any other additional information. So we know that the mower has a 30-inch wide path. And we also know that it travels 4 miles per hour. So I've gone ahead and pulled out that key information and written it down so that way I can understand a little bit better. And in this one in particular, I would really suggest definitely visualizing what this would look like in real life. So if I was riding that lawnmower, I would first need to figure out what direction I need to drive in. So I could choose to either go long ways, the 120 yards back and forth, or short ways, the 160 feet kind of back and forth. And so it doesn't matter which way you pick, but it is important that we make a decision on how we want to set it up, because that will affect the steps that follow from this. So I'm going to say I'm going to drive the long way. So I'm going to go from one edge to the field to the next, and I know that I'm going to cut that 30-inch path when I go one way. But then if I was actually mowing the lawn, what would I do? Well, I would then turn and then keep on coming back, cutting the grass for kind of like the next strip or row. And then just continuing going back and forth until eventually I've covered the entire field. So it's not really that I'm just going, say, the 120 yards once. I'm going to go over it repeatedly. And so I think that visual is really important in kind of understanding the next step. Another thing that we can kind of notice here is that everything that's been given, other than the 4 miles per hour, is a distance sort of measurement, like yards, feet, and inches are all distances. But the 4 miles per hour is the speed. So I already know that I'm going to have some sort of relationship between my speed and a distance. So speed, distance. And then one part that I forgot that's always very important is I never wrote down what I'm solving for. So if I go back and read my problem, it says how long would it take? So they're referring to time, right? So really I want a relationship that's going to talk about how time, distance, and speed relate. So maybe you remember a nice formula for it. Maybe you have to Google it and figuring out, but there is one. The distance that you travel is the rate that you travel at times the amount of time that it takes, right? Distance equals rate times time. And that's really what's happening here, right? We know the rate. I want to know the time. That's what's unknown. So the last little bit that's left over is the distance, right? We need to know the full distance that he's traveling on this lawnmower. So going back to my situation, now that I understand what's going on, I can devise a plan, right? I want to find the distance that I would be riding on this mower. And then we can use that to help figure out our time. right? So my distance, I know one path is going to take me 120 yards. What's unknown right now is how many paths back and forth I need to go. So I know I'm going to cover 30 inches each time, but my unit that I'm working with is 160 feet, which is not very compatible, right? Inches and feet, those are two different things. So what I can do, I mean, I could change 30 inches into feet, but it's not going to be a nice number. It's going to be some sort of decimal number, which we always want to avoid decimals if we can. So it's a lot easier to turn feet into inches, because then we'll just have a larger whole number. So that's what I'm going to start with, is I'm going to look for the distance. So to first do that, I need to know how many paths I'm going to cut in the grass. Okay, so what I'm going to do is take my 160 feet and convert it into inches. So maybe you already know how to do that, that you need to multiply by 12. Maybe you're not too sure and you want to set up your dimensional analysis to be really sure. So I know that 1 foot is equivalent to 12 inches. My feet would cancel out. I'm going to do 160 times 12. Which is 1,920 over 1, right? We multiply the top across, multiply the bottom across, and then the units left are inches. So that means that this full length is also 1,920 inches, and I want to cut that into, or break it into 30-inch rows. So again, when you have a unit and you're breaking it into equal sections, that's division. So 1920 inches divided by the 30 inches. My inches are going to cancel out, which is important because we're not going to want inches anymore. We want a measurement for rows. So then when I divide that, I get 64. So I have 64 rows or paths that I'm cutting out of the grass. Now it tells me the paths, but I still haven't figured out the total distance yet, because he's going back and forth 120 yards each time. So what I could do from here is say, okay, one path is 120 yards, and I'm doing that 64 times. So that's going to be multiplication because we're repeatedly adding the 120. Dimensional analysis could also be used too, right? If I think of this as a rate, this is for one path. Right, and then I can multiply that by 64 paths, right, over 1. So you can pretty much always use dimensional analysis. If there's not units there right now, you can always add units on there. So 120 times the 64 paths would get you 7,680. And this would be measurement in yards. So I know the distance. I know my rate. But again, we have this disconnect between my units. My distance is in yards, my rate's in miles per hour. So probably the easiest conversion would be changing the yards. So that's going to be the next step, is to change yards into miles. So 7,680 yards. Let's just stick it over 1 to make it a fraction. We want to change into miles. So all I can do really at this point is relate what 1 yard is to 3 feet, right? That's kind of the basic measurement that we know, right? There's 3 feet in a yard. And I set it up like that so that my yards would cancel out of our calculation. So yards would cancel with yards, but I still haven't reached miles yet. So I need to do feet to miles. So 5,280 feet and 1 mile. And again, I knew how to set that up because I want to cancel out the feet. And if I did this correctly, my final result should be just in miles, which if you look through, all the units got canceled except for miles. So then at this point, we're going to go ahead and multiply across the top. 7,680 times 3 is 23,040. Over the bottom, which is just 5,280. So once we multiply across the top, multiply across the bottom, we divide the final two numbers. And so this is going to come out to be 4.36 repeating miles. And I put a couple extra decimal points just because I'm not done yet. I mean, normally we kind of typically round to maybe 2 decimal places or 1 decimal place, but I'm not done, and I don't want to throw off my answer. So by going out to like the 4 decimal places, you usually avoid any sort of rounding error if you have to get a decimal. So that's my distance. So I now know my distance, and we also know our rate. So we know the 2 pieces of information to finally find the time. Now here, I kind of intuitively knew this distance, rate, and time calculation, and I think for the most part you guys do too. You don't necessarily have to plug it in like a formula and then solve, although you could. That's another way to solve it as well. I think kind of a stronger method, and maybe one that we're more familiar with, is using dimension analysis to get time, because you can use that too. So I can start with my miles, right? I had 4.3636 miles. Stick it over 1. And then we need to change that into miles per, change that into time by including our miles per hour. So I know I'm going 4 miles in 1 hour. So here, I actually set it up correctly on my first go, which is pretty nice. My hours would cancel out. And then my final answer has hours on top, which is important. We wanted a unit of time to come out of this, so we wanted time on top. So if we hadn't have started with the 4.36 value to start, that's okay. We would just need to have been mindful that the time needs to go on top. So if I started with a 4 miles per hour, I would need to realize that I can't put the 4 on top, because then my hour unit, the one I want to stay, is stuck on the bottom, and we don't want that. So there's more than one way to do dimensional analysis. Aside from making sure the units we don't want cancel out, the units we do want stay, we also want to be sensitive to what units are staying on top. I want the units that are going to stick around, right? I want my hour to stay on top. So you could have set it up either way there. You end up getting essentially the same result. You're going to take 4.3636 and divide it by 4. In either of these setups, it does the same thing. So 4.3636 divided by 4. And we get another decimal. So one way we can kind of let our reader know that we rounded this is with that approximate symbol. So 1.0909 is what I got. And then this is a unit of hours. So that would be totally fine if you gave me that answer in class or on an exam, because we have units and they never specified they wanted, say, this unit of time to be in minutes or hours or a combination of minutes and hours. So that would be fine. Maybe even because they didn't tell us what to round to, you could have also rounded this to 1.1 hours. That would be also acceptable. So really all that's left at this point is that last step to check to see if our answer seems correct. So there was a lot of steps involved with this one, and we could definitely backtrack and take our answer in hours and get it back to distance, and then make sure that the final distance we get is the same as the football field. Now, one warning I do have for you guys is that we rounded our answer. So if you do backtrack, you may not get exactly, say, 120 yards. It may be like 199 point something yards, because rounding does throw off your results. However, if I just look at it, the answer itself, about an hour, seems totally reasonable. So that, right, kind of in and of itself, is a way that we can kind of check to make sure that the answer we get makes sense.